Alright, welcome to the first lesson for test 4. We're going to start looking in this test ways to solve quadratic equations other than factoring. The first thing that we're going to look at is using the square root property. And this says if b is a real number and if x squared equals b, then the solutions are x equals plus or minus b. So, for example, basically what this is saying is if I have x squared equal to some number, then x is equal to plus or minus the square root of that number. And you notice we're getting two solutions here, a positive and a negative, because as you know, if I square 2, I get 4. And if I square negative 2, I also get 4. Alright, so the next part is telling you, depending on what kind of number b is, how many solutions there will be. But I've illustrated each one of these situations in the examples, so let's just kind of talk through them as we work through. So for the first one, I have x squared equals 25. So that is in the right form. X squared is equal to a constant. So I'm ready to use my square root property. So I'm just going to take the square root of both sides. And of course we're doing this is kind of the reverse process of what we did on the last test. On the last test, we were squaring both sides of a radical equation to undo the radical. So this is kind of the opposite. Now I have an exponential, so I'm taking the root to undo it. So we know the square root of a squared term is just that term. We're going to pick up a plus or minus, and we know the square root of 25 is 5. So the solutions to this equation are x equals positive 5 or negative 5. If you want to write both of them out, you can also do that and say x equals 5 or x equals negative 5. I will accept either one of those answers, okay? For the second one, my squared term isn't by itself yet. It's 4a squared. So I'm going to divide both sides of the equation by 4 so that I get my squared term by itself. Now I can use the square root property. So we know again that the square root of a squared term is just that term. We're going to pick up a plus or minus. And now you notice I have the square root of a negative number. If we're in the real number system, then we can't take the square root of a negative number. So if we were confined to the real number system, we would have to say this equation had no solutions. But if you look at the directions, it says give exact answer using radicals and I as necessary. So that tells me that the complex system is allowed. So if you remember from the last test, we can rewrite the square root of negative 4 as the square root of 1 times the square root of 4. And then by definition, the square root of negative 1 is I. And we know the square root of 4 is 2. And then I'm just going to rewrite it because we're accustomed to having the number first. And of course, if you want to write out the two cases, you can also do that. Either way is fine. For number 3, the squared term is not by itself again. So first, I need to subtract 3 from both sides. And I get x squared equals to 0. So if I use the square root property, again, the square root of a squared term is just the term. We pick up a plus or minus. and the square root of 0 is 0. So it looks like two solutions with plus or minus like the other two, but we know there's no such thing as a positive 0 and a negative 0. 0 is 0, right? So this one, the solution is just x equal to 0, and that's that middle one up here in the box, okay? Now for the last one, this one looks a little bit harder than the others. It's really not, and it's actually the one we're going to end up using the most. All I have on the left hand side is my squared term, so I am ready to apply the square root property. So again, the square root and the square, those are just going to undo each other. We pick up a plus or minus root 5. Having the square root of 5, that's not a perfect square, so I can't do anything to reduce that. So I'm going to leave it under the radical. But I don't have this equation solved for the variable yet. D is not by itself yet. I still need to add 2 to both sides. So I get D equals 2 plus or minus the square root of 5. And of course, if you wanted to write out both cases, you could say D equals 2 plus the square root of 5, or D equals 2 minus the square root of 5. Alright, so the next thing we're going to do, we're actually going to use that last case, and we're going to use some stuff that we've also previously learned. We can also solve quadratic equations by a process called completing the square, and this process requires us to rewrite one side so that it's a perfect square trinomial. So if we are given our standard form for a quadratic equation is ax squared plus bx plus c equals 0. In order to complete the square, the a must be equal to 1. So the ones that we're going to look at, a will be 1. There are cases, of course, where that's not true, and you would need to divide every term in the equation by the coefficient of a first. What we're going to try to get this to look like, if a is 1, then the a wouldn't actually be showing, right? We're going to want our squared term plus our linear term plus, I'm going to put in a blank, equals the constant plus blank. Alright, so let's look at the first problem to see what we're talking about here. So this one, I have my squared term, a is 1. I have my linear term, so I'm going to write plus blank equals the negative 8 is my constant, and I'm going to write plus blank. The next step we're going to do is to complete the square, and that step is always the same for these. I'm going to be dealing with the linear term, and I'm always going to multiply 1/2 times the coefficient of that linear term, which in this case is 1/2 times 6. Now remember, half times 6 is the same thing as 6 divided by 2. We know 6 divided by 2 is 3. If you want to put that in the calculator, you can do that too. So we're going to multiply it times 1/2, and then we're going to take the number that we get and square it. So I multiplied 1/2 times 6 and got 3. I'm now going to square 3 and get 9. That 9 is what fills in the 2 blanks that we drew up here. Alright, So now we have a perfect square trinomial on the left. Remember, the first term has to be a perfect square, the last term has to be a perfect square, and the middle term has to be 2 times a times b. And that's what we have here. The reason that that's important is because we can take that shortcut that we learned for our next step. We're going to factor the left-hand side, but we're going to factor it knowing that this is a perfect square trinomial. So we know all we have to do is take the square root of the first term as x, the sign between the two variable terms, and the square root of the last term squared. And then on the right hand side, I have -8 plus 9, which is just 1. So now if you look back at number 4 from that first section, this should look very similar. So now I have a squared term equals a constant. So now I can use the square root property. On the left hand side, the square root and the exponent will cancel. We're going to pick up a plus or minus, and the square root of 1 is 1. So now all we have to do is solve for the variable. So I'm going to say x plus 3 equals +1, or x plus 3 equals -1. I'm just dividing it up into its two separate cases, and then we can solve both of these for x. I get x equals -2, or x equals -4. So those should be my two solutions. Alright, so the next two should work very similar. The difference with number 2 is you notice my constant -3 is on the left hand side. So first we're going to need to move that across so that we can get it into that format we want, which is the squared term minus the linear term plus blank equals the constant plus blank. And from there, the process is going to work exactly the same. We're going to multiply 1/2 times b, which in this case is -2. So -2 divided by 2 is -1. And then we're going to square -1, and that's going to be +1. So that's what I fill into both of my blanks. Now I'm just going to factor my perfect square trinomial. So we know we take the square